Hey, iqkid here. We're going to talk about dot products today. And so first we're going to cover just general how to do dot products, and then we're going to talk about how they can be used to solve problems in regards to work. Okay, so let's start by defining what exactly a dot product is. So a dot product is basically just a shorthand way of writing the product of the magnitudes. So a dot product takes this general form. So vector A dot vector B is equal to AB cosine of theta. So theta is the angle between A and B. Okay, so what we're looking at is these are the two vectors, and vectors are made up of both magnitude and direction, but a dot product only deals with the magnitude. So you're really getting rid of the vector part and just taking the scalar or the magnitude. So these two are going to come down, and those are just numbers. So just numbers, not vectors. So I'll put in parentheses, so no direction, which means we're allowed to multiply them. Normally you're not allowed to multiply vectors because you can't really multiply directions. If you had one person going south at 45 miles an hour in a car and another person going north in a car at, or let's say northeast, just to make it complicated, at 30 miles an hour, let's say, how are you going to multiply those directions? Okay, so that's why you're not allowed. So this allows us to multiply the number value of like how fast they're going, like with complete disregard to the direction. Okay, and then the theta helps us with the direction. Okay, so with this you can write it in terms of work, and force and distance. So work is equal to force and distance. Okay, so force and distance, kind of ran out of the room, but oh well. So to write it as a dot product, we have W is equal to F dot D. So we're getting a non-vector answer out of two vectors because we're going to write F times D cosine of theta. So these are the scalar, or just the numbers involved with the force and the distance. Okay, so dot products can also be written in another way. They can be written in terms of direction. So A sub x, B sub x, plus A sub y, B sub y. And then if you're also dealing with the z direction, then it would also be plus A sub z, B sub z. So to write this in terms of component directions, you'd have F sub x, D sub x, and then plus F sub y, D sub y. And then if you're dealing with z's, again, normally you won't, but if you are, then you'd have F sub z, D sub z. Okay, so something that you need to know is these directions are represented by interesting units they're something you probably haven't seen before. So it's going to look like that and that. So this is called I hat, and that's equal to the x direction. So it's one unit value, and the unit would be I hat. 1 unit value in the x direction. And these, they don't mess with your math at all, except to know where to put numbers in equations. So then j hat, and then the last one is k hat, and that's for the z direction. So that's 1 unit value in the y direction, and that's for j hat direction. Okay, and then k hat is 1 unit value in the z direction. So to help you understand, I'm going to do a little graph. So basically what we're talking about here is this. So this is the coordinate plane. So this is the y direction, or j hat. This is the z direction, or k hat. And this is the x direction, or I hat. So if we were to have, say, let's say we had, for example, the vector A is equal to 1.0 I hat plus 1.0 j hat plus 2.0 k hat. So then we'd have 1 in the x direction, then we would have 1.0 j hat in the y direction, and then we would have 2.0 k hat in the z direction. So then you take those and you put it in the vector. That's how far it would go in each direction. Okay, so with that, I'm going to do an example. And if you have any questions, they will likely be answered by the examples, but if they aren't, you can contact me through email. I'll respond as quickly as I can, probably maybe same day, but if not same day, then definitely by the next day. But I check email pretty often, so if it's not like dead in the middle of the night or needing it by sometime in the afternoon and you email me in the morning, then I should have a response back to you. So you can also contact me online. I just made a website, and I will leave the link to that in the description, and I'll also leave my other email, which I'm checking probably every other day. So you can also contact me through that if it's not very urgent. Okay, so now let's do an example. Example here is, what is the dot product of vector A is equal to 2.0 x squared I hat minus 4.0 x j hat, and the vector B is equal to 11.0 I hat plus 2.5 x j hat. So right here we're not dealing with the third dimension or the z direction, so we're not, because we don't have any k hats. So let's write the formula for step 1. So A dot B is equal to AB cosine of theta is equal to AX BX plus AY BY. Okay, so then notice we're not doing anything with work here. This is just standard dot product. Okay, so then step 2 is to identify the pieces. So in this one, we're going to look at our original problem, and we're going to see that in the x direction, because we're going to use this formula first. In the x direction, a sub x is equal to 2.0x squared. So that's the I hat portion. Then b sub x is equal to right here, 11.0. And so for these two, you associate the x direction with, so you associate the I hat components with x. So then a sub y is equal to 4.0x, negative 4.0x, sorry. And so something to take note of is that you can still have x in there. It's not saying it can't be in the y direction. It's just another variable is all it is. Okay, so then b sub y is right here, 2.5x. So then these you associate j hat with y. Okay, so now that we've identified the pieces, let's look at step 3, which is to plug and chug. So in step 3, we're going to plug it in. So let's write it first. So a dot b is equal to a sub x b sub x plus a sub y b sub y. Okay, so to plug in, we're going to look at this. So to carry it down further, we have a sub x is 2.0x squared, and then multiply that by b sub x, so 11.0, and plus a sub y is negative 4.0x, and b sub y is 2.5x. So now let's simplify. So we have 22.0x squared minus the value 10.0x squared. Okay, so then your final answer, a dot b, is going to be equal to 12x squared. Okay, so now let's do an example with work. In this example, we're going to find, or we are going to use this. So a constant force F is equal to the value 2.0 I hat plus 4.0 J hat, and that's Newton's, acts on an object as it moves in a straight line path. If the object's displacement is d is equal to the value 1.0 I hat plus 5.0 j hat meters. Calculate the work done by the vector f using these alternate ways of writing the dot product. So in part A, we are going to use W is equal to the, let's go ahead and write the standard part, so f dot d, and then that's equal to, this is the part we're using, so f d cosine of theta. So in part B, we're going to use the other one, so work is equal to vector f dot d is equal to f sub x d sub x plus f sub y d sub y. Okay, so for part A, step 1 is to draw a picture. So let's go ahead and do that. So here's our coordinate plane, and let's say that is f, and let's make that d, and we're going to name this angle beta, so beta, and then this angle is going to be theta, and this whole angle right there, so both angles combined, is going to be alpha. So then alpha is equal to theta plus beta. Okay, so then in step 2, we're going to find the force. So the formula that we need, or what we need to know, is that the force is equal to the square root of I hat squared plus j hat squared. So basically it's like the distance formula. It's basically the same thing. We're just finding the magnitude. So this, if we're going to plug in, then we're going to get f is equal to the square root of 2.0 squared plus 4.0 squared. So I'm going to pull up the original problem so that way you can see where I got that. So if you look at f here, the I hat portion is 2.0 and the j hat portion is 4.0. Okay, so then to go ahead and finish this out, f would be equal to the square root of 4.0 plus 16.0. So f is equal to the square root of 20.0, which can be simplified, but we don't need to do that at this moment. Okay, so then step 3, which is really another part of step 2, but since it's separate from finding force, exactly, this is step 2, step 3, step 4, and step 5 are all really one big step broken down into 4 parts. So we're going to find alpha in this part. So alpha, to find alpha, you want to take the inverse tangent of the opposite angle, or of the opposite over the adjacent, over the sides. So to get this, use the directions. So we're looking at tangent -1 of So let's look at this. And so if this is the angle right here, so this is the angle. So we want the opposite, which is the y direction, over the adjacent, which is the x direction, and then the vector f is the hypotenuse. So we have 4.0, the y direction for f, over 2.0, the x direction for f. And we're going to get that theta is equal to tangent -1 of 2. Okay, so then let's go on to step 4. So in step 4, we're going to find d. So to find d, we do the exact same thing as with the force, except we just plug in the components of d. So the square root of I hat squared plus j hat squared. So this is going to be square root of 1.0 squared plus 5.0 squared. So simplifying, we get 1 plus 25. So then d is equal to the square root of 26.0. Alright, so then for step 5, we're going to find beta. So in this step, to find beta, you do the exact same thing as for finding alpha. So beta is equal to tangent -1 of the opposite side over the adjacent side. So with beta though, we're going to use d, because if you look here, when we're using alpha, that was all of the angle for f. When we're talking about beta, that's the angle for d. So we're going to use beta. So with d, we're going to plug in and get that opposite was the y direction. So that's 5.0 over the x direction, that's 1.0, and so we're going to get b is equal to the inverse tangent of 5.0. Okay, so then our final step is to plug and chug. So in this step, we're going to go ahead and write the formula. So we have work is equal to f d, so force times distance, cosine of theta. So then that's equal to force times distance cosine of alpha minus beta, because if you remember, we have alpha is equal to theta plus beta, so therefore we have theta, so we can take that and bring it down like that and get theta is equal to alpha minus beta, just with some simple algebra. Okay, so we have that. So now let's go ahead and plug in. So work is equal to, the square root of 20, so that would be the force, times the square root of 26, that would be the distance, cosine of alpha, which is tangent -1 of 2, minus beta, which is the inverse tan of 5. So then work is equal to 22 joules. So the unit of measure for work is joules, by the way. Okay, so now we have the answer to that, to part A. So now let's move on to part B. In part B, the first step is to identify the pieces. Okay, so to start, let's write down the formula. So if you remember, it was work is equal to force dot distance, and that's equal to Fx dx plus F sub y d sub y. Okay, so then let's find our component pieces. And so I'll pull up the original problem for you, so that way if you didn't write it down, you can see it. So it's right there and right there. So f of x is going to equal 2.0, d of x is going to equal 1.0, f of y is going to equal 4.0, and d of y is going to equal 5.0. Okay, so if you remember, you associate I hat with x, and you associate j hat with y. Just a reminder. Okay, so this is really simple because all you have to do is plug it in. Alright, so step 2 is to plug and chug. So work is equal to f of x dx plus f of y dy. So work is equal to 2.0 times 1.0 plus 4.0 times 5.0. Alright, so then we get that work is equal to 22 joules. So you should get the exact same answer, because if you remember, that is the same as f d cosine of theta. It's just a different way to go about solving it. Alright, so that is all I have. If you have any questions, if any of this was confusing, because I know it could be kind of confusing with I hats and j hats and alpha and beta and theta and stuff. So if you have any questions, you can definitely contact me through email or through the comment section below. Also, I just created a website, so if you want to learn a little more about me or try and get in contact with me to do maybe something one-on-one, or you have a question that you can't really word very well over email, you need a more responsive way of communication, then you can contact me through there. Yeah, so have a wonderful day, and IQ Kid signing off.